As we can now create a basic program which says hello world, we can now move on to actually generating the IL statements we need. So this is the third part in our plan. And the way we're going to do this is we're going to write a simple program that uses each of the available instructions, then run our existing compiler which will generate the C#. We'll then open that C# DLL in ILSpy, and that will show us the exact IL opcodes we're going to need to emit from our code. So let's begin by doing that. So we don't want to use loops, we just want to use all the other commands at the moment. Loops we're going to do in the final part. So we're going to ask for some input from the user, which is going to get stored into the current location on our tape. We're going to increment that value by 1. So if the user typed in A, that will now become a B in effect. We're then going to move to the next location in the tape and ask the user for another input, and this time decrease its value. So if the user typed in Z, that would now become Y. We're now going to print that on the screen, move back to the first location and print that one out. So if the user enters AZ, we're going to print out YB. So we should just run that. So that's going to compile our C# version to start with. And that's one we just generated, that's good. So if we type in AZ, that does YB, which is what we'd hope. So that's working, so we can now look at that in ILSpy. So we just drag in the DLL rather than the exe. And there's our program. So you can see, after a bit of setup, we ask the user to enter the key press. We then increase that value by 1, we move the data pointer, ask the next key press, decrease the value by 1, display that, move back to the first position and display that. So you can see each of our commands is nicely matches to a set of IL codes. But the first thing we need to do is actually define some variables. So we have 3 variables in our program. We have the actual tape, which is our array of bytes. We have the data pointer, which points to where we are in the tape at the moment. And we also have this console key info. So that's used when we're doing the key press, because to do a key press we actually do system.console.readKey.keychar. So we have to have an intermediate result. The thing to note is within the IL code we never refer to these variables by name. We only ever refer to them by their numbers, so 0, 1, 2 and so on. So since I recorded the last video, I noticed that I'd actually missed off the keychar method, so I've just added that in up here, and I've also added comments so we can see which are which. So the first thing we need to do is declare our variables. So we need to say we're going to initialize variables. So we're going to add a new variable definition. So we're going to have 3 variables, clear them. So the first one is going to be an array of bytes. So that's the array type, and that takes the type of the array as its parameter, which is module.system.byte. So that's our tape at position 0. The next one is our data pointer, so that's going to be a int32. That's at position 1, that's our pointer. And then finally it's going to be our system console key info type, which is going to be position 2. So now we've emitted those variables, so that will handle this top bit. So now we need to actually initialize the variables. So what we're doing here is we're actually doing the new array of size 10,000, and we're going to set our data pointer initially to the value of 5,000. So I'm going to copy exactly what those codes were shown by ILSpy, so I'm just going to take them straight out of my notes to save keying them in. And I'm going to comment out our hello world statement as well. So what we have here is, first of all, we have a not, which is no operation, so that doesn't do anything at all, but it is somewhere you can set a breakpoint later on. We then put the value 10,000 onto our stack, and we then call new array. A new array takes the first or the topmost value off the stack to be used at its size. And then the stack now contains our new array of size 10,000, which we then take off the stack and store into position 0. So that's doing our new byte array in effect. Now we want to set our data pointer to be 5000. So we do this by putting the number 5000 onto the stack, and then we say take the value off the top of the stack and put it into location 1. So what I'm going to do is just run our program now, just to make sure we've got the first bit working okay. Okay, so we haven't, so we've got a problem here. So, member system is declared in another module and needs to be imported. That's because I'm using the type rather than the reference to the type. So you find the type in the assembly, and once you import it, called import reference, it gives you back a reference to it, and it's that we need to refer to, not the original type. Okay, that's worked, which is half the battle. And it's generated a DLL, so we can look at our generated DLL and IRSpy as well. Okay, and as you see, we've got our local variables defined, and we've got our initialization happening, which looks good. So we can now actually loop over the instructions and actually generate IL for each of our instructions. So all our instructions are in our code block. We've only got a single block now because we've already lowered it. So we can just loop over each instructions, and we can pattern match on the instruction to work out what type we're doing. So switch instruction. And it doesn't really matter which order we do them in, but we might as well start with read from console, which is the complicated one. So if we go back to our first example, so this here is all our read from console, so asking for the key press. So again, I'm just going to copy the code out of my notes to save just keying it all in exactly as it is. Okay, and yeah, so the way that this works is we first of all put the tape and the current value of the data pointer onto our stack. We then call our readKey method, which returns a system console key info, which we store into our variable 2. We then take that out of variable 2 and put that onto the stack, so we can then call the getKeyChar method on that. So now we've got the character of the key that was pressed at the top of the stack. We now convert that to a byte, and then we then store it back into our array, which is pointed at this location. Okay. So one of the good tips is if you're using IRSpy, you can actually move your mouse over individual instructions, and it also explains what they do. But the main thing to note is everything's stack based. So whenever you're going to make a call, the arguments for that call are the things that we show on the top of the stack at the moment. So I'm just going to refactor this slightly into a different method, which is going to be init read console. So we might as well do its pair, which is write to console. So this one's slightly simpler. Again, we put onto the stack the tape and our data pointer. We then take the element which is pointed to by our data pointer, which is of type byte, and we convert that from, what do we do? We convert that into a char, and then we call write method to display it on the screen. So again, I'll just extract that, emit write. Okay. So now we're on to actually incrementing and decrementing the value at the pointer So So this bit here, so our current value we want to be able to increase and also decrease. So increase and decrease is the same thing really, only one uses an add and one uses a subtract. So we can do some generic code for that. So the first one was increase. We call it increase? Yes, increase. Alright. So what we're going to do then is emit increase. So module. Do we need module? Maybe let's write one to begin with. I'll write one and then I'll make it generic. So at the moment we just want to be able to increase it by 1. So it's the same idea. We push the tape onto the stack and our data pointer onto the stack, and then that allows us to read the current value, which we then duplicate it. So that's on the stack. So this is our quantity, which we're going to. So we put onto the stack the quantity we're going to increase it by, which in this case is going to be 1. And then say if the quantity is greater than 0, we're going to be doing an add. If the quantity is less than 0, we're going to do a subtract. We need to store it as a byte, so we need to convert it from an integer back into a byte, which we then store back into the tape because we've stored the location that we duplicated them to begin with. So all of that can be extracted into emit increase, and it's going to be +1. That's now our quantity. Okay, so now when we do decrease, that's straightforward, as that now becomes -1. So in here, we always put the positive version of the number on the stack, so if -1 comes in, we still put 1 onto our stack, but because we're calling a subtract, that's still going to work out. The other one we need to handle is if we optimize the code, then we may have replaced these increase and decrease calls with calls to increase cell, which can be for a different value as well. So increase cell, and this time it's not -1 or 1, it's i.quantity. So this would be the case where our program, for example, contained ++. We've replaced that with an increase cell of a value of 2. So similar to increase and decrease is actually moving the data pointer itself left and right. So that's move left and move right. So move right is increased by 1. So it's the same idea. So it'd be emit move is +1. So move is slightly simpler, as you can see, because all we are doing here is actually loading the current value from location of our data pointer at location 1 onto the stack, putting the number 1 onto the stack, adding them together, and then storing it back into location 1. So again, our version is slightly more complicated because we're going to be able to handle different quantities and also subtracting. But it's the same idea. So we're loading the data pointer onto our stack. We put a positive version of our quantity onto the stack. If the quantity is greater than 0, that means we've got to add the values. If it's less than 0, we've got to subtract the values, and then we store the result back onto the stack. So we don't actually need module this time. And we can quickly do move left, which is -1. And finally, the move is the optimized version for different quantities. Okay, so we haven't done the loops yet, but we should have done the IL for all the other instructions now. So if we run this, it should generate us the full DLL. Okay. We'll look at an IL spy first, I guess. So we can do a reload in here. Okay, so it's generated quite a lot of code, which is a good start. And this is our code we've just generated. Yeah, so we can try running that. So I've already copied in the config files it's going to need. .NET. Okay, now let's have let's do the wires XC. So that's working perfectly. So in the fourth part, we will look at adding support for loops.